Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is application of derivatives. In this video, we'll be focusing on NCERT solutions for exercise number 3. In the first problem, we need to find the maximum and minimum values of the function given by f of x equal to 2x minus 1 the whole square plus 3. We will expand this. F of x equal to 4x square plus 1 minus 4x plus 3. So what is the condition of maximum minimum? We have to take the first derivative. So first derivative is constant term, derivative is 0. So this f dash x will make it equal to 0 for getting maximum or minimum. So x will be equal to half. Now we will check the second derivative. Shall we check second derivative? Yes. Whether this is maximum or minimum, we have to check the second derivative. So this is the first derivative. So we will find f double dash x is 8. This is greater than 0. So x equal to half is minimum. So we will substitute what is the minimum value. What derivative condition tells at what point minimum is coming. To get the minimum value of the function, we have to insert x equal to half in this equation. We have to insert that. So f of x equal to half equal to 2 into half minus 1 the whole square plus 3. This will become 0. So we will get 3. So 3 is the minimum value of the function. Find the maximum and minimum values of the following function given by this. We know sin x takes value between 1 and minus 1, that we are knowing. Similarly, sin 2x also takes value between 1 and minus 1. Now we'll add 5 throughout. So this will be minus 1 plus 5 sin 2x plus 5. We are trying to get this expression here by writing like this, less than or equal to 1 plus 5. So this is 4 less than or equal to sin 2x plus 5 less than or equal to 6. So sin 2x plus 5 takes value between 4 and 6. So minimum value equal to 4, maximum value equal to 6. Find the local maximum and minima. Find also the local maximum value also we need to find. So we can easily find g dash x 3x square minus 3. We'll equate it to 0 to get maximum or minimum. So this will give x equal to plus minus 1. Now we will find g double dash x whether there is a minimum or maximum, that we can check only with the second derivative condition. So this will be 6x. So at x equal to 1, now we are taking 1 by, at x equal to 1, g double dash x equal to 6, which is greater than 0. So x equal to 1 is minimum point. This is minimum. Similarly, at x equal to minus 1, we are taking 1 by 1 this. So g double dash x is putting minus 1 here, be minus 6 less than 0. So x equal to minus 1 is maximum point. So we have to find the values also. We will substitute these values 1 and minus 1 into this. So g of x at x equal to 1 will be 1 cube minus 3 equal to minus 2. Similarly, g of x equal to minus 1 the whole cube minus 3. Correct? So how much we are getting? Just let me cross check it. So we'll get this as 1 cube minus 3. 1 minus 3 is 2. This is minus 1 cube so this will be 2. So this will be the minimum value and this is the maximum value. -3 into -1 also will be there. So maximum value, the minimum value of function is -2 and it occurs at point x equal to 1. The maximum value is at maximum value of the function is 2 and it occurs at x equal to -1. Prove that the following function do not have maxima or minima. So what is the condition of maxima or minima is f dash x equal to e power x for this function. Derivative of e power x is e power x itself. So f dash x equal to 0 for maxima or minimum, we have to do this. So e power x equal to 0. However, there does not exist any value of x for which ex equal to 0. E power x equal to 0 cannot be made by choosing any x. For any x, e power x cannot be made 0, cannot be made 0. So e power x does not have any maxima or minima. Find the maximum profit that the company can make if the profit function is given by this. So we can find p dash x minus 72 minus 36x. We are taking derivative of this. Derivative of this is 0. So we equate it to 0 to get it maxima or minima. So 36x equal to minus 72, x equal to -2. So this is the value we get, but we don't know whether this is maxima or minima. So we will find p double dash x, which is derivative of this, which is minus 36 less than 0. So x equal to -2 corresponds to maxima. But to get the value of the function, we have to substitute x minus 2 back to p of x. So p of x equal to -2 will substitute here. 41 minus 72 minus 2 minus 18 minus 2 the whole square. So how much we get this? We get this as 113. So this is the maximum value of the function. Find both maximum value and the minimum value of this function. So this, let it be this f of x. So f dash x will be, derivative of this is 12x cube minus 24x square minus 24x square plus 24x minus 48. So we have to make this equal to 0 to get maximum or minimum. We will divide throughout this equation by 12. So we will get x cube minus 2x square plus 2x minus 4 equal to 0. We will take x square common here. So x minus 2, this also x minus 2 will be there, plus 2. We will equate it to 0. So x square plus 2 into x minus 2 equal to 0. This can never be made 0 because this is x square term. Even if you put negative, this will become positive. If it is positive, so no real root exists for x square plus 2. So x minus 2 will be 0, implies x equal to 2. So we get x equal to 2. Now we have three critical points, 0, 3 and 2. So we need to check the function values at these points. So f of 0 will do, put in this equation. So this will be 25. Similarly f of 2 will put 2 in this equation. So we will get how much? Let us check it. We will get minus 39. Similarly f of 3, we want to check at 3 also. F of 3 we will put back in this equation. So we will get 16. F of 3 as 16. We need to find maximum. The maximum value is 25 of this function and the minimum value is minus 13. It occurs at x equal to 0 and x equal to 2. In this problem we need to find, for the function sine 2x, its maximum value within this range 0 to 2 pi. So how do we proceed? Let f of x equal to sine 2x, then we will find its derivative, correct? So f dash x will be equal to 2 cos 2x, so this will equate it to 0, so implies cos 2x will be equal to 0, or cos 2x will be equal to pi by 2. So x will be, pi by 4 is one solution, so x will be equal to, this is cos pi by 2. So x will be, pi by 4 is one solution, general solution is 2n plus 1 pi by 4. So we get different critical points. If we put n equal to 0, we'll get pi by 4. If we get n equal to 1, 3 pi by 4. Similarly 2, it is 5 pi by 4. And so on. We can even get 7 pi by 4. But beyond that, it will become more than 2 pi. So we have to stop. And these two are also critical points. So we need to check the function values at these points. So these are the critical points. So we'll just evaluate the function value. So f of 0, when we put f of 0 in this, sine 0 is 0. Similarly, when we put f of pi by 4, so this will become sine pi by 2, which is 1. Similarly, we can do for others also. F of 3 pi by 4 equal to minus 1. F of 5 pi by 4, which is equal to 1. F of 7 pi by 4 also equal to minus 1. And f of 2 pi is equal to 0. We know that. So we need to attain the maximum value. Does the function at what points? So it is getting maximum at pi by 4 and 5 pi by 4. So this function attains maximum at pi by 4 and 5 pi by 4. What is the maximum value of this function? So we can write this as sin x plus 1 by root 2 cos x. We are writing in sin a plus b form. So this can be root 2 sin x plus pi by 4. This is 45 degrees and that is the value of 1 by root 2. So now we got this. So how do we proceed further? We know that sin x plus pi by 4 can take value between 1 and minus 1. So multiplying throughout by root 2. So minus root 2 less than root 2 sin x plus pi by 4 less than or equal to root 2. But this quantity is sin x plus cos x. So minus root 2 less than or equal to sin x plus cos x less than or equal to root 2. So the maximum value of sin x plus cos x is root 2. So that is the answer. In this problem, we need to find the maximum value of this function in the regime 1, 2, 3 and also in the regime minus 3 and minus 1. So how do we proceed? Let f of x equal to this 2x cube minus 24x plus 107. So f dash x is equal to 6x square minus 24. We need to equate to 0 to get maxima or minima. This will give x equal to plus minus 2. So what happens? Also we can find second derivative test equal to 12x. So what happens at x equal to plus 2? We'll take from here. At f double dash x equal to 24. We'll substitute here x equal to 2. So 24 is greater than 0. So x equal to 2 is minimum point. Similarly, at x equal to minus 2, f double dash x is equal to minus 24, which is less than 0. So x equal to minus 2 is maximum point. But we need to find the maximum value of this first in the interval 1 to 3. In the interval 1 to 3, 2 is also there and 2 is the minimum point, but we are looking for the maximum point. So 1 and 3 only need to be looked, but we can do for all points. So let us do f of 1. We are finding the function values by putting 1 in this equation. So we'll get the value as 85. Student can do himself this. Similarly, f of 2 will be 75 and f of 3 will be 89. So in this regime 1 to 3, in this interval 1 to 3, the maximum value of function is 89. Now what happens the maximum value of function in minus 3 and minus 1? In this interval minus 2 is present, so that is the maximum value. So we can directly find f of minus 2 and put it back in this equation. So we will get f of minus 2 as minus 16 plus 48 plus 107. This will give us 139. The maximum value of function in this interval minus 3 to minus 1 is 139. It is given that at x equal to 1 the function attains the maximum value on the interval this. Then we need to find the value of a. So let f of x equal to x power 4 minus 62x square plus ax plus 9, f dash x equal to 4x cube minus 128x plus a. This should be equal to 0 for getting maximum or minimum, and also given it is coming at x equal to a, so f dash x equal to 1 will be 4 minus 128 minus 4 minus 124. This should be 124 derivative. So this is 124 plus a is equal to 0. So a equal to 124 minus 4 equal to 120. This is the value of a. Find two numbers whose sum is 24 and whose product is as large as possible. So if one number is x, then another number will be 24 minus x. Why? Because the sum is 24 and their product will be x into 24 minus x, and we need to make this product as large as possible. So p dash will be, we will write this as 24x minus x square. So p dash x will be 24 minus 2x. This will be equal to 0 to get maximum or minimum. So 2x equal to 24, x equal to 12. So one number is 12, another number is also 12. The two numbers are 12 and 12, and their product maximum is 144. But you may be wondering why we say this is maximum. It can be, this condition is also for minimum. So let us find double derivative as a second check. For this will be minus 2. So this will be less than 0. So x equal to 12 is maximum for maximum condition. In this problem we need to find two positive number whose sum is 16 and the sum of whose cube is minimum. So how do we proceed? So let one number be x, the other number will be 16 minus x since the sum is 16, and now the sum of cube is minus, sum will be x cube plus 16 minus x the whole cube. Now s dash will be 3x square plus 316 minus x square into minus 1. So this we need put it 0 to get maximum. On simplification we get x will be equal to 8. Just simplifying this will give x equal to 8. So the two numbers are 8 and 16 minus 8, which is also 8. So 8 and 8 are the two positive numbers. Now this sum we can also find s double dash and show that s double dash is greater than 0. So it corresponds to minimum condition. We can easily show, taking another derivative of this function, we can easily show that this is greater than 0. square piece of tin of this side is to be made into box without top by cutting square from each side. It is like this. We have a square of width 18 and 18. We need to cut square of size x. Here xx and make it a open box. So the length will become 18 minus 2x. This length of that box will become 18 minus 2x. Similarly, its width also will be 18 minus 2x and height will be x. So volume will be 18 minus 2x into 18 minus 2x into x. So we'll get this as 18 minus 2x the whole square into x. Now we can find v dash, the first derivative. So x into 18 minus 2x into 2 into minus 2 plus 18 minus 2x the whole square. First function into derivative of second, second function into derivative of first. So we can get this as 18 minus 2x as common and we'll get 18 minus 16x, 6x. This will equate it to 0, so we'll get x equal to 9 and 3. But if we take x equal to 9, then the length of that box will become 18 minus 2x is 18 minus 2 into 9, 18, which will become 0. So x equal to 9 not feasible. So x equal to 3 is the solution. In this problem, we need to show that for a right circular cylinder of given surface area and maximum volume, its height is equal to diameter. So h equal to 2r need to be proven. So we are given a cylinder like this. So radius is r and height is h. We know that the surface area is equal to 2 pi r square plus 2 pi rh. This is 2 pi r square is the curved surface area this side and 2 pi rh. Sorry, 2 pi rh is the curved surface area and 2 pi r square is the top and bottom surface area. So what we do, we take h from here and put it in the volume equation. So from this we will get h equal to s minus 2 pi r square by 2 pi r, and we'll substitute this into volume equation is pi r square h, pi r square into h. Basically what we have done, we have now all converted this into r form in the radius. So now we can find dv by dr and equate it to 0, that we can easily do. So that we'll get half s minus 6 pi r square. This will be equal to 0. So s will get as 6 pi r square. So now s is 6 pi r square. We substitute back in this equation. So 6 pi r square equal to 2 pi r plus h. Solving this gives h equal to 2r. That's what we wanted to prove. So in this problem we need to show that for a right circular cylinder, right circular cone, of least curved surface and given volume has an altitude equal to h equal to root 2 times the radius. This we need to show for a right circular cone. So how do we, for a given volume means v equal to 1 by 3 pi r square h. So we will find h will be equal to 3v by pi into 1 by r square. This we take it as some constant equal to k by r square. So we got the volume. From the volume equation we got h. Now we will find the least curved surface. So we have to find the surface area. Curved surface area is pi RL, but what is L is root of h square plus r square. So we can write S equal to pi r, h square is k square by r4 plus r square. So we got this. Now what we do, finding derivative of s with respect to r for this is difficult. So we just substitute z equal to s square. So we'll get z equal to, now taking square root of this, pi square, get k4 r square plus r power 4. We'll get this. Now we can find dz by dr equal to, and put it equal to 0. So what we'll get? We'll get pi square minus 2k square r minus 3 plus 4 r cube. This equal to 0. This will give r power 6 equal to k square by 2. But what is our first equation? First equation is this. H is given by this. This we call 1. This we call 2. So from 1 and 2 we can get h equal to r root 2. We can easily deduce. Equating these two, we can easily deduce h equal to r root 2. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.